Bottled gas is a term used for substances which are gaseous at standard temperature and pressure and have been compressed and stored in carbon steel, stainless steel, aluminum, or composite bottles known as gas cylinders. Gas state in cylinders. There are four cases: either the substance remains a gas at standard temperature but increased pressure, the substance liquefies at standard temperature but increased pressure, the substance is dissolved in a solvent, or the substance is liquefied at reduced temperature and increased pressure. In the last case, the bottle is constructed with an inner and outer shell separated by a vacuum so that the low temperature can be maintained by evaporative cooling. Case I =, the substance remains a gas at standard temperature and increased pressure, its critical temperature being below standard temperature. Examples include air, argon, fluorine, helium, hydrogen, krypton, nitrogen, oxygen. Case II =, the substance liquefies at standard temperature but increased pressure. Examples include ammonia, butane, carbon dioxide, chlorine, nitrous oxide, propane, sulfur dioxide. Case III =, the substance is dissolved at standard temperature in a solvent. Examples include acetylene. Note: acetylene cylinders contain an inert packing material, which may be a gamma-sen, and are filled with a solvent such as acetone or dimethylformamide. The acetylene is pumped into the cylinder and it dissolves in the solvent. When the cylinder is opened, the acetylene comes back out of solution, much like a carbonated beverage bubbles when opened. This is a workaround to acetylene's property to explode when pressurized above 200 kPa or liquefied. Case IV =, the substance is liquefied at reduced temperature and increased pressure. These are also referred to as cryogenic gases. Examples include liquid nitrogen, liquid hydrogen, liquid oxygen, carbon dioxide. Note: cryogenic gases are typically equipped with some type of bleed device to prevent overpressure from rupturing the bottle and to allow evaporative cooling to continue. Expansion in volume. The general rule is that 1 unit volume of liquid will expand to approximately 800 unit volumes of gas at standard temperature and pressure, with some variation due to intermolecular force and molecule size compared to an ideal gas. Normal high-pressure gas cylinders or bottles will hold from 200 to 400 atmospheres. The atmosphere unit's pressure held by the bottle is equivalent to the number of volumes of standard temperature and pressure of the gas held by the bottle for an ideal gas. Special handling considerations. Because the contents are under high pressure and are sometimes hazardous, there are special safety regulations for handling bottled gases. These include chaining bottles to prevent falling and breaking, proper ventilation to prevent injury or death in case of leaks, and signage to indicate the potential hazards. In the United States, the Compressed Gas Association sells a number of booklets and pamphlets on safe handling and use of bottled gases. The European Industrial Gases Association and the British Compressed Gases Association provide similar facilities in Europe and the United Kingdom. Nomenclature differences. In the United States, bottled gas typically refers to liquefied petroleum gas. Bottled gas is sometimes used in medical supply, especially for portable oxygen tanks. Packaged industrial gases are frequently called cylinder gas, though bottled gas is sometimes used. The United Kingdom and other parts of Europe more commonly refer to bottled gas when discussing any usage, whether industrial, medical or liquefied petroleum. However, in contrast, what the United States calls liquefied petroleum gas is known generically in the United Kingdom as LPG. And it may be ordered using by one of several trade names, or specifically as butane or propane depending on the required heat output. Color coding. Different countries have different gas color codes, but attempts are being made to standardize the colors of cylinder shoulders. Colors of cylinders for medical gases are covered by an International Organization for Standardization standard, ISO 32. But not all countries use this standard. Within Europe, gas cylinders' colors are being standardized according to EN 1089-3, the standard colors applying to the cylinder shoulder only. That is, the top of the cylinder close to the pillar valve. In the United States, color coding is not regulated by law. The user should not rely on the color of a cylinder to indicate what it contains. The label or decal should always be checked for product identification. European cylinder colors the colors below are specific shades, defined in the European standard in terms of array coordinates. The requirements are based on a combination of a few named gases, otherwise on the primary hazard associated with the gas contents. Specifically named gases, acetylene cylinders are maroon. Argon cylinders have a dark green shoulder. Carbon dioxide cylinders have a gray shoulder. Chlorine cylinders have a yellow shoulder. Helium cylinders have a brown shoulder. Hydrogen cylinders have a red shoulder. Nitrous oxide cylinders have a blue shoulder. Nitrogen cylinders have a black shoulder. Oxygen cylinders have a white shoulder. Based on gas properties, toxic or corrosive gas cylinders have a yellow shoulder. Flammable gas cylinders have a red shoulder. Oxidizing gas cylinders have a light blue shoulder. Inert gas cylinders have a bright green shoulder. Toxic and flammable or toxic and corrosive gas cylinders have yellow and red shoulders. Toxic and oxidizing or corrosive and oxidizing gas cylinders have yellow and light blue shoulders. Gas mixtures, mostly for diving cylinders are left unpainted, or painted to prevent corrosion, often in bright colors, most often yellow, to increase visibility. This should not be confused with industrial gases, where a yellow shoulder means chlorine. Air diving cylinders have a white and black coated shoulder or a white top and black band. Nitrox cylinders, a diving mixture of nitrogen and oxygen, have a white and black coated shoulder or white top and black band. Can also be coated with green stripe on yellow bottom. Hollyox cylinders, a diving mixture of helium and oxygen, have a white and brown coated shoulder. Trimix cylinders, a diving mixture of helium, nitrogen and oxygen, have a white, black and brown segmented shoulder. See also, diving cylinder, gas blending, industrial gas. References. Notes standards ISO 32, gas cylinders for medical use. Euro marking for identification of content. CENEN 1089-3, transportable gas cylinders, Part 3, color coding. External links, virtual anesthesia machine, 6 different color codes for medical gas cylinders, hoses and outlets, British Compressed Gases Association. Euro color coding of cylinders. Air Products. European Gas Cylinder Identification Chart. Compressed Gas Association, Gases and Welding Distributors Association, European Industrial Gases Association, British Compressed Gases Association.